recording. Let's take a look at solving this equation. This time it's not an exponential equation, it's a logarithmic equation. We see that because we have the log here in the equations. And this time it's really actually a straightforward problem to solve because we have a single logarithm equal to a single logarithm, and these logarithms, just like the exponential functions, are one-to-one functions. So if the numbers are the same, these arguments have to be the same. So if you have a log equal to a log, now there can't be a coefficient in front of that log. You can't have other terms. You can't be dividing by some value. It's just log equals log. Then you can set these two arguments equal to each other. Let's collect the r's on the left-hand side and the constants on the right-hand side. So let's add 3 to both sides. -3 plus 3 gives us 0, and -1 plus 3 gives us 2. Now let's subtract 2r from each side. 4r take away 2r's is 2r. 2r minus 2r is 0. So we have that 2r is equal to 2. Divide both sides by 2, and I think it's pretty clear that r is equal to 1. That does not give us an extraneous solution. If you plug in 1 here, you have 4 minus 3, which is a positive value. You plug in 1 here, and you have 2 minus 1. When you have log equations, you must make sure that the solutions are not extraneous. All right, so let's move on to the next one. We have another log equation. Now this time ln, that's a natural log. That's just telling us that the base is base e. In the previous problem, this log here was a common logarithm, and that base was 10. Now in this problem, we do not have a log equal to a log, so we can't solve it in the same way. On the left-hand side, we notice that we have two terms. The term that contains our variable is this first term. We need to add 4 to each side of this equation. When we add 4, we isolate the term that has our variable. If we look at that term, it has two factors, the 2 and then this natural log of -2a minus 7. We need to divide both sides of this equation by 2, and we get our natural log now by itself. We've gone as far as we can go with properties of equality. This does not mean natural log times this binomial. What we can do is convert this equation that's in logarithmic form to exponential form. This base of this logarithm is e. This logarithm equals an exponent, so we can write this as e raised to the 4th power is equal to this -2a minus 7. Now this is a two-step equation. To get a by itself, we'll add 7 to each side and divide by -2. I wrote the variable on the left-hand side, e to the 4th plus 7, and now divide both sides by -2, and you have your final answer. So I hope that helps, and I'll talk to you later.